Used by Langen and Sondermann since 1922. To comfortably transport passengers and the heaviest of loads, the plant here in Lünen develops and produces primarily parabolic and coil springs. International customers such as Bombardier, Siemens Transportation, and Alstom rely on the quality of the springs produced here. An integral part of the manufacturing process is the hardening of workpieces by means of shot peening. We at Aktos have delivered 2 shot peening units for this very purpose. First, let's take a closer look at the parabolic springs. After being heat treated, these workpieces must be cleaned and descaled. The Aktos unit was equipped with a roller conveyor that moves the workpieces through the hardening process in a closed loop. Thus, the loading station is also the unloading station in this case. After the springs have been pre-cleaned and small slag inclusions have been removed by grinding, the surface is ready for the shot peening process. The workpiece carriers each accept 2 springs, which are manually exchanged by the operator once operation begins. After a protective cover is raised, the spring is put under tension beneath a hold-down device. The necessary pre-tensioning of the spring is achieved through the application of 20 tons of press force and an upstroke of 200 millimeters. Workpieces can have a maximum length of 1,750 millimeters. Sensors located at transfer points in the roller conveyor automatically activate the next step in the transport process. As a pair of springs like this one passes through the unit, the tension side and the edges of the springs are surface hardened. The transport process is programmed to proceed at a feed rate of 3 to 10 meters per minute. The vestibules are equipped with wear-resistant rubber curtains that prevent the escape of blast media. A switching threshold begins the blast process as workpieces enter the unit. A worker-accessible noise protection booth was installed to reduce noise levels from 90 to 80 dBA. In this unit, 4 Aktos high-performance turbines deliver the desired hardening results. When the blasting program first starts, the turbines are in so-called idle mode, and turbine run-up takes place without blast media. The dosing devices release the blast media only after workpieces have first entered the blasting chamber. The flow rate of the blast media is controlled in each case by an electro-pneumatic valve. A glance through the maintenance opening of the blasting chamber reveals the turbine ejection vanes, the highly wear-resistant protective cladding made of hardened manganese steel plates, and the conveyor rollers encapsulated in labyrinths made of tool-grade steel. After passing through this zone, the workpieces reach a blow-off device that removes stray blast media and returns it to the blast media process loop. A good blasting result can be achieved on a lasting basis only when high-quality blast media is used. For this purpose, 5 tons of rounded wire shot is stored in the storage bin located above. After blasting, the shot is collected in a hopper and transported to the cleaning station in the uppermost part of the unit by a screw conveyor and bucket elevator. There, an air classifier removes dust and undersized shot. The Aktos PF4 cartridge filter unit continuously cleans the extracted air and removes and deposits dust in a paper sack. A differential pressure control unit automatically activates the cleaning cycle for the cartridges. An additional downstream safety filter keeps residual dust content below 1 milligram per cubic meter, which makes it possible to return the exhaust air to the production hall. This saves valuable heating energy. The second Aktos unit is used to harden coil springs. Workpiece lengths can range from 150 up to 1,000 millimeters. With a maximum diameter of 450 millimeters, individual workpieces can weigh up to 150 kilograms. The actual batch is delivered to the entry side of the blast unit by an indoor crane. A kind of stair lift makes it easy to separate and correctly load the springs. The unit shown here transports about 60 springs per hour. The blasting task includes the cleaning of the workpieces and shot peening to a hardness level of 40 almond. Workpieces are transported using 2 parallel conveyor shafts and a single lifting beam. The shafts transfer the rotational motion to provide for a uniform shot peening effect and thorough all-around coverage of the workpieces. The lifting beam provides the longitudinal motion through the unit. Using a frequency-controlled gear motor, transport speeds of 1 to 4 meters per minute can be programmed into the manufacturing procedure. Behind the housing, we find 2 high-performance Octos turbines, each of which is rated at 22 kilowatts. Processing of the blast media matches that seen in the previous unit. However, the amount of dust produced here on a daily basis is clearly higher because the workpieces processed in this line do not arrive pre-cleaned. In addition to the non-visible changes in the tension of the workpieces, the cleanness of the coil springs is actually quite impressive. The workpieces can proceed right away to the next processing step, which in this case is powder coating. The springs made by Langen and Zonderman are so widely used in the railway industry that we have probably all enjoyed the level of travel comfort that has its roots here in Lünen. What blasting challenge of your own